All right, let's find the derivative of this function, right? So you can actually kind of tell that this is not going to be one of our straightforward derivatives. It's going to use multiple rules together. Specifically, I'm looking at the chain and product rule, right? So let's kind of tackle this guy out. So let's just let's find m prime of x. Okay. So if we're trying to do that, I'm going to potentially be using the product rule. Now, before I actually think about finding the derivative, I'm going to write m of x as purely exponents. So you have 9 minus 2x to the power 1/2. This represents the square root. And you have x squared plus, I'm going to write this as 2 times x to the power negative 3 because we're using the reciprocal rule of exponents, right? So the two rules I just kind of employed, x to the power a over b is equal to the root of b, right? The index of b, the radicand x to the power a, right? And I also use x to the power negative a is equal to 1 over x to the power a. Okay, so you should be familiar with some of these exponent rules. Now what we want to do here is, if I want to find the derivative function m prime of x, I'm going to do the derivative of my factor to the left here, 9 minus 2x to the power 1/2, x squared plus 2x to the power negative 3, plus the derivative of x squared plus 2x to the power negative 3 times 9 minus 2x to the power 1/2. Okay? And then what we want to do is we're going to simplify this guy out. Okay, so we're going to utilize the chain rule here, so we get 1/2 9 minus 2x. So it's really important to kind of work through this slowly. It's really easy to make a mistake here. Negative 1/2. Then what I'm going to do is I'm going to do the derivative of the inside, right? So I'm just going to separate this. 9 minus 2x. And then we're going to multiply this portion by x squared plus 2x minus 3, right? Plus the derivative of this portion here, right? So you have x squared plus 2x to the power negative 3, so you have 2x minus 6x to the power negative 4, right? And then you need to multiply this by 9 minus 2x to the power 1/2. Okay? Now what we should do here is we should kind of, first let's do the derivative and simplify this a little bit further, right? So the derivative of 9 minus 2x, so we get 1/2, right? What you want to do with the negative exponents, we might want to just kind of put them on the denominator. We'll kind of work with that. So we have 1/2 9 minus 2x to the power negative 1/2. So I'll do that for the next step. But here we have negative 2, okay, times x squared plus 2x to the power negative 3 plus 2x minus 6x to the power negative 4 times 9 minus 2x to the power 1/2. Now you can already see that there is a 1/2 times negative 2, so this guy cancels that. So you do have a negative here, right? So what you could do here is you have a negative 1/2 here and you have a 1/2 here. Let's see if we could factor out the negative 1/2. Okay, so, and you can notice here that this one is completely different from this, right? So if you wanted to just write this as positive exponents, you could write this as x squared plus 2x to the power negative 3. You have 9 minus 2x to the power of 1/2 plus 2x minus 6x to the power negative 4. And our whole point here, you want to simplify this as much as possible. Okay? So if we're simplifying this as much as possible, we can understand that this is to the power of 1. Right? And in order for us to combine these functions, you need to make sure the denominators are the same. So what you could do here is you could multiply this by 9 minus 2x to the power 1/2. And I'm going to do the same thing for the denominator here. And you can notice here that because you have the same base and you're multiplying exponents, these two will add up, right? So when you do that, you basically will get x squared plus 2x minus negative 3 plus 2x minus 6x to the power negative 4 times 9 minus 2x to the power 1. Okay? And really it's up to you if you want to further expand this, but I think I'll just stop here, right? Because it would just continuously keep going. There isn't any common factors that can really expand, so I think I'm just going to stop here in terms of the derivative function. So this is m prime of x. So you can see that This is somewhat of a complex type question. It's a lot of algebra, right? Right, but you want to factor as much as you can and try to create as many positive exponents as you can. Obviously, I could have made another positive exponent, but I think we would just kind of stop here because this is as far as we can kind of go. Okay, so if you did want to combine these any further, you could change 2x to the power negative 3 as 2 over x cubed, and 6x to the power negative 4 as 6 over x to the power 4. But beyond that, there really wouldn't be any point in this. You wouldn't be able to factorize it any further. So we'll just kind of stop there.